so combinations of functions. You guys are probably used to adding numbers and variables together, but in this video we're going to talk about what you do when you apply order of operations into functions. So there's gonna be five main types of combinations we're gonna cover in this video. It's gonna be addition, subtraction, multiplication, division, and this other one called the composite. So for the addition, if you would distribute this, it would end up just being f of x plus g of x. So that is when you add one function and another function. And likewise for subtraction, instead of adding, you would subtract. So this is just a way to get from this notation to what the actual thing is. But then for the multiplication, it'll be f of x times g of x, and for f over g x, that would be f of x over g of x. So in a way, when you see this, you don't really have to be intimidated anyway. It's if you distribute it, it ends up just being one function plus another function, one function minus another function, and so on. But this one is a bit tricky because we've never seen anything like this before when we added like numbers and stuff. So what this function is, or this notation is f of g of x. So this is a function inside a function. So what we do here is we get one value. So let's say we're going to split it up into f of x and g of x. So let's say we have a value for x. Let's say x is like 3 or something, and then g of x is like x plus 2. So then when we could break this into two parts. So you have f of, we already have it up here, so we could just use that. Instead of it being x here, the x, let's say we could just call it, or we could just use it as g of x. So in order to solve for this quote-unquote f of x, it's really just f of g of x. So we could kind of use g of x as a instead of x, we might use something else, but yeah, we could use like f of y or something like that. So to solve for y, we solve for g of x, and to solve for g of x, we use the x value. So we're gonna go back over here. So g of 3 would be 3 plus 2, that'll be 5. So that's what g of x is when x equals 3. So now that we know what g of x is, we know what y is as well. So y would be 5. So this way, we know what we can solve for f of y. And let's say like f of y is like x squared or something like that. Now that we know, or it's like y, yeah, actually, I think it would be better if we switch this back into x. So f of x would be x squared. And now that we know what g of x is, and that is essentially like, and that is inside the f of x notation, then f of x would be f of g of x, and since g of x is 5, then it'll be f of 5, and that'll be 5 squared, which is 25. Alright, let's do some examples. So let's say f of x would be x minus 3, and g of x is x squared plus 5. So let's find f of g of x, or instead of f of g of x, let's do f of g of 3. So this is the equivalent of f of 3 plus g of 3. And we could just substitute in 3 for the x in both of these functions. So this would be 3 minus 3 plus 3 squared plus 5. And the 3 minus 3 cancel out, so that'll be 0. And that leaves us with 9 plus 5. The 9 is from the 3 squared. And this composite function will give us, this combination of function will give us the value of 14. So if we use the same functions for f minus g of x, that would be or instead of x, let's just use 3 again. So it'll be f of 3 minus g of 3. And that will give us 3 minus 3 minus the quantity of 3 squared plus 5. So in this case, the 3 also cancels out because it's 3 minus 3. But over here, you have to distribute the negative. So it'll be negative 3 squared minus 5. And that'll be negative 9 minus 5, which is negative 14. Alright, so let's move on to the multiplication one. F of g. In this case, instead of using 3, we could use, let's try using 5. So in this case, it'll be f of 5 times g of 5. And when you substitute it in, it'll be 5 minus 3 times 5 squared plus 5. And when you solve, or when you simplify this, it'll be 2 times 25 plus 5, 2 times 30. That'll give you the value of 60. And let's do the division one. F over g of 5. That'll be f of 5 over g of 5. So when we substitute the 5 into the functions, it'll be 5 minus 3 over 5 squared plus 5. That'll be 2. And we just use the value over here we got for 5 squared plus 5. When we simplify it, it'll be 30. And this will simplify to 1 over 15. Alright, now let's do the composite one. So it'll be f of g of x. I'm going to make sure this is a open circle instead of a dot, so it won't be confused with multiplication. So this is the same thing as f of g of x. And what you want to do first is to solve for this inner value. And instead of x, we could do we could substitute in for, let's just say 2, just for the sake of the example. So let's solve for g of 2 first. G of 2 is going to be 2 squared plus 5 when we substitute in 2 for x. That'll be 4 plus 5 and 9. So now that we know g of 2 equals 9, we could substitute it in back to this original equation. So it'll be f of 9. Now one thing to point out is even though x is equal to 2, we're not using x to, we're not substituting in x for inside f of x, because in this composite function, the f of x is using the value of g of x, and the g of x is using the value of x. So this x acts as a placeholder for g of x instead of the actual x value. So just one thing to look out for. So for f of 9 now, we substitute in 9 for x, or up here in this equation, and it'll be 9 minus 3, which is 6. So the final answer would be 6, and 6 is the equivalent of f of g of 2.